Welcome to the PhotoModeler Scanner Multiple Pairs tutorial. This tutorial demonstrates working with more than one set of photo pairs to generate a mesh that could not be obtained using a single pair. We start with the project pillarstart.pmr opened. This project contains 6 photos, which we have oriented using the strips of targets attached to the pillar. A few points have been added near the edges to help generate a better approximate surface, as discussed in Tutorial 3. Turning on Camera Station Display, you can see we have 3 pairs of photos covering different areas of the pillar, but with overlapping regions. This pair is separated horizontally, while this pair is separated vertically. The direction of the separation does not matter. We open up the Dense Stereo dialog and choose the pairs of photos to generate the point meshes. An easy way to identify the pairs in this project is to sort by angle. The low angle pairs are the ones to use. We will increase our sampling rate to generate a dense point cloud. Our extents are defined by trims, and we can leave the default depth range. Press Execute, and all 3 pairs of photos will be processed to generate 3 individual point meshes. We are not running any meshing steps, as we will go back and run those later. We skip ahead to where the point meshes have been created. You can see we have 3 point meshes created from each of the pairs, all with different numbers of points. If we look at the 3D view, you can see we have 3 individual point meshes that overlap, giving us coverage most of the way around the pillar. Opening the point mesh table, you can see a listing of all 3 meshes, how many points are in each, and selecting a mesh in the table also selects it in the 3D view. We will save this project as pointclouds.pmr. We have some noise points that have been generated, possibly due to poor trims or other settings. We will use Point Mesh Edit mode to clean these up, selecting and pressing the Delete key. We will skip ahead to where we have finished cleaning up the noise points. We will now generate a single triangulated mesh that encompasses all 3 clouds. We use Select All via Ctrl-A to select all 3 point meshes, and open the Modify Point Mesh dialog. We choose Register and Merge to combine the 3 point clouds into one unified cloud. We will denoise the cloud and apply a bit of decimation to smooth out the data for triangulation. We will triangulate the data. Do a bit of decimation on the triangles. Fill holes. Unify normals. Fill fjords. And do a bit of smoothing. We hit Execute. And our triangulated mesh is created. Here is our result in the 3D viewer. If we hide the point mesh layer, the points are no longer visible, and we are seeing only the triangulated mesh. Switching to a wireframe view allows you to see the individual triangles. Switching to a shaded view allows you to view the detail of the triangulated model. When we switch back to a textured view, you can see how parts of the model are textured correctly, while others are not. This large black region is the most obvious issue. A point mesh textures only from a single photograph. In this case, it is textured from photo 5. You can see that photo 5 does not extend to the bottom of the pillar. The bottom of the pillar is only visible in photo 1 and 2. This black region represents the area that is not visible on the photo the texture is assigned to. If we had chosen photo 1 or 2 as our texture photo, a view from this angle would look correct. But these back sides would not be assigned the correct texture. There is no way to texture this point mesh correctly from a single photo. To resolve this, we can create a surface from the point mesh and use the powerful Photo Modeler surface texturing tools. First, we will reduce the point mesh to a manageable triangle count. We select the triangulated mesh, which has 60,000 triangles, open the Point Mesh Modify dialog, and choose Triangle Decimation. Increase the percent to 95. We will also smooth the resulting decimation. Hit Execute. The mesh has been reduced to around 3,000 triangles. We can add our original mesh to a new layer and hide it. This view is just the decimated version. We select our lower triangle count mesh and choose Convert Point Mesh to Surface. Now we can hide point meshes and just show surfaces. If we turn on Quality Textures, you can see the resulting textured surface. Note this project had masks assigned to the photos to mask out the black idealized region when generating quality textures. Generating a quality texture for a large number of triangles over a large number of photos can be quite slow. Where applicable, you should try to use a single photo material instead of the default multi-photo material, as this calculation will be much faster. Here is our resulting surface, textured from multiple photos combined into a single standard photo modeler surface. You can now perform any operations with this surface that you would a regular photo modeler surface, exporting it, creating an orthophoto, etc. We will save this project as pillardone.pmr. We will discuss export now. If you want to output point mesh specific data, you can select a point mesh and use the Save Point Mesh command. You can also load point meshes into a project, assuming they have the same coordinate system. To finish with, we will export an orthographic photo of the front of the pillar. This is using the surface we generated from the point mesh, creating an orthophoto just as you would with a regular photo modeler project. Here's our preview. We can choose a file size and export as pillardone.jpg. Here we can see the generated orthographic view of the front of the pillar. This concludes the tutorial on working with multiple photo pairs, converting to a regular photo modeler surface, and export.